Hi everyone. I've been meaning to record some Python videos for a while now, and I thought maybe to create a series of videos that we go through different basic data structures in different languages and compare them to each other. So I thought maybe to start with Python, Swift, Dart, JavaScript, and Rust. So these 5 languages. And I thought maybe to start with Python because we have IPython, which is a really good environment for actually testing our code in the terminal. So in this video, we're gonna look at Python lists, and we're gonna have a look at some different functionality of lists when they're useful. And how I prefer to use them in Python, and different methods that are quite often used in lists in Python. So let's get started. Here I have a terminal window, and for this video I'm going to use just IPython. You can just use Python, I believe so. You can just write Python and you're in a Python environment, but I prefer to use IPython. If you don't have IPython, you can install it with pip. So you can just say pip install IPython, and we can give it a try and see what happens. So, okay, and there's a new version of pip that I can install, but I don't have to do that now. So that's how you get IPython. So then you write IPython here. Now, a list or array, as it is called in many programming languages, is a data structure that, in a way, is a linked list. In that, wherever you are in the array, you can go forwards and backwards. Items themselves don't have a connection to the items after them or before them, but the array or the list has. So, lists are useful when you want to collect a series of items that are somehow related. For instance, if you have a class that describes a person and you want to store instances of that class inside your list, then you can, for instance, say here's a father object of that person class, here's a mother, here's a son and daughter, and then you can put them into this collection list or array. And then you can access them, you can iterate over them, and iteration means that you go through them one by one with the for command in Python, as we will see soon. You can remove items from the list, you can change items in the list, you can reverse them, you can pretty much do anything with those items in the list. But what's important is that lists in Python are very similar to how they are in Dart and Swift and Rust, but they're not so similar to arrays in JavaScript, in that in JavaScript you don't necessarily have to populate the list from 0 to 10. You can actually assign an object to index 10 in the list that has no other items in it. So there are some differences between Python lists and JavaScript, for instance. But if you program in Swift or Dart or Rust, C, C++, any of these things, Python lists are very similar to arrays in those, or arrays or collections, how you want to call them in those languages. So let's have a simple example. So what is a list? So in Python, if I, for example, have foo and then I have bar and I want to put them together, and just say it like this becomes a tuple. But if I want to put them inside a list, then I will, for instance, say names is equal to, and then I start a curly bracket and I say foo bar. Now names became a list. I can then say names, and you can see the values in there. I can say names append. This is a function on list in Python. It's very useful. If you know, if you have a computer science background, it's kind of like push in a stack. So if I, for instance, say Baz here, and I say names, you can see foo bar Baz are in that list now. Now, You can also insert items at specific indices. So you can say insert, for instance, test at the index of 0. And let's see, cannot be interpreted as an integer. Oh, I should specify the index first. I'll say 0, for instance, and then test. And I'll say names. As you can see, the index specifies where in the list the new item has to appear when you're calling the insert function. And indices in lists in Python are 0 based. That means here, if you look, test has the index of 0, foo has the index of 1, and bar has the index of 2, and baz has the index of 3. Now, you can also say names count. This is a really useful one argument. It's just a variable. Wait a minute. Names count takes exactly one argument. Oh no, I don't actually, no, I didn't want to use the count. I want to say len names. And you can see there are 4 items in there. Sorry about that. Count, I believe, is a function that counts the amount of times an item appears on the list. This is not what we're going to do. We can use a len function to actually find out the number of items in the list. Now, this is a very very common pattern that you can see in software engineering, where people say, for instance, names, and then they want to specify the index of the last item. So then say len of names -1. And what this does in principle is that it takes the length of the names, which is 4, and then -1 becomes 3, and it takes that item as at that index. And if you look at the items in our list, 0 is test, 1 is foo, 2 is bar, and 3 is baz. So 3 is basically the index of the last item in this particular list with 4 items. So the last items index in a list in Python is always the length of that list -1. So this is a good thing to know for you. So you can see names, len names -1 gives us baz, and that is the last item in the list. So that's one thing. And this is kind of like a subscript. The syntax of square brackets and then the index is called a subscript. And then there are so many other functions that we're gonna have a look at. And the next one that I wanna talk about, now that I've talked about push, is the pop function. So if I say dummy is equal to names.pop, and then you can see what dummy is. What the pop function does is that it actually pops, as does any stack operation. It pops the last item in the list. So here we have the last item baz, and then I say names pop. It gives us the last item in the list. And then if I print out names, you can see baz has been removed. So you've now learned append and insert and pop. The next thing to know about lists maybe is how to iterate over them. Iterating over a list means that you go through the items one by one in the list to do some operation with them. And the syntax for that is using for. And I can say for n in names, and I can just say print n. You can see it prints out test foo bar. It goes from item 0 at index 0 and then 1 to, it basically goes through the items in the list for us. Now, you can also, for instance, say if an operation that you may want to perform on lists typically would be to find out if this names list, for instance, has, or any list has, an instance of something that you're thinking about to extract from it. For instance, names, and I can say index foo, and it's telling me the index of this item is 1. It means that it's appearing in the list and its index is as 1. I can do the same thing here, and I say test, and it will give me the index 0, as you can see here, and then I can also say bar, and then you can see it gives me the index of 2. Now what happens if I give it Baz, which doesn't appear in the list anymore? And you can see that it throws a value error for you here, which you can catch. So you can say, for instance, value is not found, and then you can say try, and in the try statement you can say value is equal to names index of Baz, which we know is gonna throw an error, and then we're gonna say catch, and then we're gonna say value error, except I think. And then in here we're gonna say we could not find Baz in the list, and then execute this, and you can see that we could not find Baz in the list because attempting to find the index of an item in a list where the item doesn't exist is going to throw or raise a value error exception for us. So that's for index. Now, index also allows you to find an item in a list after a specific index. Now I'm not going to go through details, but you can also do, for instance, like this. That means find Baz in this list, but jump over the first 2 items. You can also look at this index of 2 as the start point, the start index of the search. But I prefer to look at it as jump over 2 items. It's just a bit easier for me to understand. Instead of having to calculate like 0, 1, and then it's going to start at 2, which means it basically has jumped over the first 2 items in the list. So think of it how you want, but that's how it works. And you can see it's throwing the same error, and I can say begin from 0, and Baz doesn't exist, and I can say foo, and it's going to find it for us. Okay. Now, you can also use, I'm going to print names here. You can also use names.clear if you want, and this is a clear function, doesn't take any parameters if you just want to use it as it is. It, as its name indicates, it's going to clear the list for us. So we just say names clear, and then if I print names here, you can see names is empty. I can assign new values to it, foo bar, names, just like that. Names clear, names is empty, assign the values to it, names, just like that. So that's for the clear function. Another useful function of lists in Python is the reverse function. And if I say reverse, you can see the order of these items is changed. Now, it's not a very good example right now because there's only 2 items in the list, but when there are 3 or more, then the order change is a lot more prominent. So I can say names is foo bar, and then Baz, abs, maybe names reverse, and then names. Baz bar foo. So it's important to know that reverse doesn't like return necessarily the reversed list, but it actually reverses your list. And this is not really similar to so many other languages. In Swift, for instance, the convenience is that if a function starts with, if it ends with reversed, it means that it returns the operations result. But here, since it says reverse, it means that it's performing the operation on the list itself. So it's quite obvious that names reverse is going to reverse names. So these are some basic functions that you're going to need. Now, we've talked about clear, but there's also sometimes a need for removing a specific item from the list. And you can do that using the delete function. Just as you can delete the variable names itself, you can also delete items in the list. So if I go back to assigning names, Then I can say delete names item 0, which means the first item. And then I say names. You can see foo has been deleted. And then I can say delete names 0 again. It's going to remove bar. And again, delete name 0. And now names is empty. So if you get, for instance, the length of this, length of names, you now is 0. So this is a really good way for you to basically cherry pick things from a list and also be able to delete the things that you're not interested in. So as we've seen now, by assigning items to our array of names here, or list of names, you can also have lists in lists. And this is usually useful when you're developing, for instance, games where you have to work with different types of matrix. So here's, for instance, we can create a list that has a list. As you can see here, there are 2 lists in that parent list. You might be asking, how do we go through this? Because if I say for I in numbers, and I say print I, then I'm just going to get the lists as they are printed to the screen. So the first item is 1, 2, 3 as a list, and the second item is 4, 5, 6 as a list. But you can also go through these by changing your statement here and saying for Jaden in I, and then print J. You can see then it's going to go through, first going to go through the outer list and extract the 2 elements that are in that outer list, and then it's going to go through each one of those as if they were lists, which they are, and going to print the specific items, or the first to the last item of those inner lists. So you can also do some really funky stuff with lists. I don't want to go into so much details about like functional programming, but you can, for instance, use the map function with a lambda to transfer items inside a list to some other items. For instance, if I say names is equal to foo, or maybe names is already present. Yeah, it is present. Let's say you want to reverse every item in the list. So foo is going to be oof, bar is going to be rap, and baz is going to be zap. Then what you can do is to say, for instance, reverse is, or revved is equal to, then you create a map. And then you pass a lambda function here. And then we say, let's say the input is name. And then we want to say name reversed. And then we go through names like that. Now, let's see if I actually know. There was one parenthesis too much. Revved is equal to map of lambda function of name reverse, or no, name, for instance. I'm going to use this syntax to reverse every string in the names array. Like this. And this is going to be kind of a map. And you can transfer this, basically type or change the type of this, make it a list. And you can see every item in our name list is now reversed. Now, I don't want to go into like very advanced topics about lists and make everybody scared, but I think this should be like a data structure that you slowly start learning, because you're going to have lots of use for it, not only in Python, but also in other languages. And getting a good grasp of how lists work is very important, because lists implementations are quite different under the hood in different programming languages, but essentially they do the same thing, in that they're kind of like a doubly linked list that you can traverse from the beginning to the end and then extract items, delete items. Now in different languages where type specifiers for variables can determine whether there are constants or not. It changes how lists work in that sometimes they're immutable and sometimes they're not, but in Python you don't have to worry about that. So you create an instance of list and then you can work with it. And as the last subject, just to as the last item in this topic, you can also create empty lists, and you can do that by, for instance, saying names is equal to an empty list. And then you can say names append foo, and then names. You can see foo is there. Names append bar, and then you can see names has foo and bar. And as we talked about it, you can also clear the entire content of names by just saying names clear, and then names is an empty array. So there you have it. This is a basic introduction to lists in Python. Of course, I recommend you to go and read the documentation for lists on Python's website. It's very well documented with examples. So please have a look at that. And if you have any questions, let me know. Thank you.